In this video, we're going to factor trinomials where the leading coefficient is not 1. That means that factoring them is going to have a few more steps. But first, we're going to start by just reviewing distributing or foiling these two binomials here. So you get 2x times 3x, which I know is 6x squared, 2x times negative 4, negative 8x. You have negative 5 times 3x, which is negative 15x, and negative 5 times negative 4, which is a positive 20. And just like all of our other polynomials, we always want to see if we can combine like terms or anything like that to condense it down some. So this is going to become 6x squared minus 23x plus 20. So these are the types of trinomials that we're going to be factoring now. Okay, so notice that this trinomial has a number in the front. And this is what I mean by the leading coefficient is not 1. This time it's 6. That means that our possible answers are more of them. There's more possible answers, so we have to take more things into consideration. We can't factor this only by looking at the 20. We have to take the 6 into consideration as well so that we can factor and get back to this factored form. So we're going to do a couple examples on the next page that show us how to go through the pattern of working backwards, aka factoring trinomials. Okay, so we're going to start with 2x squared plus 5x plus 3. Normally, we would just pay attention to the last term, which is 3, but this time we're going to also focus on the 2. If that was a 1, we wouldn't care, okay? So 2 times 3 gives us the number of 6. So now that is the number that we are going to list all the factors of. If you remember previously in the easier trinomials, we only listed the factors of the last number. Now we're taking into consideration both. Now when I look at these, they both could give me 5, right? If I subtracted, I would get 5 here. If I added, I would get 5 there. But since this trinomial has a plus sign at the end, I know I'm looking for something that's going to add to give me 5, which is the middle. So I'm going to actually choose the 2 and 3. So this time, we are not going to write our final answer like we did before. We're going to rewrite the problem with 4 terms. Okay, we're essentially turning it into a grouping problem, which is one of the factoring methods we learned in the beginning. So what does that mean? That means instead of writing 5x, I'm going to write 2x and 3x. So I have 2x squared, which is just coming down. I have plus 2x plus 3x because those are the numbers we chose. And this plus 3 is coming down. So now as you can see, my trinomial now has 4 terms. Now I can just factor it by grouping. So actually from here, this is all a previous method. So from here down is not new. We're going to split it in half, and we're going to proceed to find the greatest common factor 3 times, okay? We're going to find the greatest common factor once on the left, once on the right, and then once by comparing. So I'm going to write that GCF 3 times. We're going to do it on the left. We're going to do it on the right. And then we're going to compare the two sides. Okay? So on the left side, I have a 2x in common. And I'm left with x plus 1. And on the right side, I have a 3 in common. And I'm also left with x plus 1. Keep in mind, this is how I know I'm on the right track, because my GCFs, when I compare sides, they should always match. If they don't match, you have to go back, okay? So on the left side, my GCF was 2x. On the right side, my GCF was 3. And now when I compare the two sides, my GCF is x plus 1. So my final answer here is going to be the part that they have the same, the x plus 1, and the part that's left over, the 2x plus 3. And that is my factored final answer for the first one. If I FOIL this or multiply, I should always get back to the original trinomial, okay? So let's look at the next one. Now we're going to focus on the 9 and the 2. Okay, 9 times 2 gives me 18. So 18 is the number that I am going to find all the factors of this time. So we have 1 and 18. And we have 2 and 9. And we also have 3 and 6. So again, since my last term is a positive, right? I know I want something that's going to add to give me 9, which is going to be the 3 and the 6. Now here, we're also going to pay closer attention to the signs, but first we're going to go ahead and rewrite it with 4 terms. So I'm going to have 9x squared, and my negative 9x is going to be written with the 3 and the 6. And notice, my 3 is going to be negative, and my 6 is going to be negative, because how else am I going to get negative 9? And I'm just bringing down the plus 2. Okay. Once I'm here, I have my 4 terms. I'm going to go ahead and do my grouping, which again is finding the GCF 3 times. So I'm going to split this in half. On the left side, I have 3x in common. And what's left is 3x minus 1. And on the right side, I'm actually going to take this negative out. So it's going to be negative 2. And that's also going to leave me with 3x minus 1. Now note, if I didn't take out the negative, my GCFs here wouldn't match. The signs would be off. So that's usually a hint when that first term, when you split them in half, is negative. You usually want to take the negative out. So my final answer here is going to be 3x minus 1, which is the part that matches. And then 3x minus 2 is the second part. Let's just do a couple more. It really is about frequency. The more problems you practice, the easier it becomes. So keep going. Okay, this next one. Now we're going to focus on 10 and 3. So 10 times 3 gives me 30. I'm going to list all the factors of 30. And so just right off the bat, I noticed this one and this one both can give me 13, depending on whether or not I'm adding or subtracting, right? So I'm going to look at that third term because that's really where the hint is. The third term is negative, so I definitely want to subtract to get 13. So I'm going to choose the 2 and the 15. And those are the numbers I'm going to use to rewrite my problem with 4 terms, making sure the signs are all proper. So I have 10x squared. I'm going to go positive 15x and negative 2x, because again, that's how I'm going to get a positive 13, and the minus 3 is just coming down. I'm going to go ahead and split it in half and go ahead and find the GCF 3 times. So I have 5x here, so I'm left with 2x plus 3. And on the right side, I can see I have a negative 2x minus 3. That means I got to take out that negative 1, because that's how my 2x plus 3 is going to match. And now I can write my final answer. The part that matches, 2x plus 3, and then the part that's left over, 5x minus 1. Let's keep going. We have here 3 times 6. So this time 18 is my number. So I'm going to go 1 times 18, 2 times 9, and 3 times 6. Again, I'm looking here. My third term is a negative, so I want something that's going to subtract to give me 7. That's definitely the 2 and the 9. This time when I rewrite my 4 terms, I'm going to make the 9 negative and the 2 positive because I want it to give me a negative 7x. Once you have those 4 terms written out, just go ahead and split them down the middle and start taking out that GCF 3 times. So we have 3x here, which leaves me with x minus 3. And here we have 2, which also leaves me with x minus 3. So now my final answer is the part that matches and the part that's left over. I believe I have one more example here, or 2 more. Okay, so these 2 are special because it really does show a combination of things. Just from looking at these, they look like trinomials, but the exponents are too big. As you can see, I have a cubed up here and a 5th to the 5th power here. So something I haven't really been saying out loud, but it is something you want to get in the habit of. That is looking for a greatest common factor no matter what type of factoring problem you have. Let that be the first thing you look for. So when I'm looking at this, it doesn't look quite like any factoring type, so I'm definitely going to opt for the GCF. The negative in the front, I definitely want to take that out. 8, 2, and 3 unfortunately don't have anything in common, but they do all have an x term. So when I divide out a negative x from everything, let's see what we have left. I have a positive 8x squared, a negative 2x, and then just a negative 3. So now, after I take out this GCF, I still have this trinomial in the middle that I should at least check to see, can I do anything? So it looks just like the trinomials from the other pages. So we are going to start by focusing on the first and the last term, which is going to give us a 24. 8 times 3 is 24. Here I am listing all the factors. I really like to list them all before I even try to find the answer. I know some of you guys like to rush and get to the answer, but now again, since that last term is a negative, I want something that's going to subtract to give me this 2. When I look at all of these, 6 and 4 is the only way I'm going to subtract to get 2. So this negative x, I'm just going to kind of ignore for now. He is part of the final answer, but I'm not going to do anything with him right this second. So I'm going to rewrite my trinomial with 4 terms. So I have, let me change colors. I have 8x squared. I'm going to do minus 6x plus 4x, and then there's my minus 3. Honestly, the order, I could have wrote positive 4x and then minus 6x. And honestly, that really doesn't matter. It all works out at the end. Just make sure you're putting the signs in the proper place. Okay. So now that we have it written with 4 terms, we're going to go ahead and split it down the middle. On the left side, I have a 2x in common. So I'm left with 4x minus 3. And on the right side, they don't have anything in common, but we got to take out something. So we're going to take out a positive 1 because that leaves us with the 4x minus 3. And that's what we want because they match. So there's my final answer. 4x minus 3 and 2x plus 1. So as you can see, don't forget, I almost forgot it. Don't forget the GCF that you took out in the beginning. It is part of your final answer. So this is what we would call like a combination problem. Not only did you take out the GCF, but you also had a trinomial stuck inside. So we're going to look for the same thing on this next one. 12, 17, and 6 don't really have anything in common. But I do see they have x's. So the GCF of exponents is always the smallest one. So I know x cubed is my GCF here. So I'm going to divide all of these by x cubed, and I'm going to be left with a trinomial inside. So I'm going to have 12x squared minus 17x, and then this is going to be plus 6. So now, these are bigger numbers, but just use your calculator, you know. What is 12 times 6? I'm going to get 72. And then I want factors of 72. 3 and 24. 72 and 4. So we got 18 and 4. We also have, let me see. Obviously 6 and 12. We have 8 and 9. There's a bunch, right? So I'm looking for what, I got a plus sign here. So I'm looking for something that's going to add to give me 17. Well, that's going to be my 8 and my 9. So again, I'm going to ignore the x cubed for a little bit and just rewrite my problem with 4 terms. So I'm going to have 12x squared, and they're both going to be negative. Negative 8x, negative 9x, because that's the only way I'm going to get negative 17. Bring down the plus 6, and I'm going to split it in half from here. So we got 4x leaves us with 3x minus 2. And this, I'm going to take out a negative 3, because that's how I'm going to get 3x minus 2. I see my common factor here. So my final answer is going to be 3x minus 2, 4x minus 3, and then don't forget the x cubed you took out in the beginning. So that whole thing is your final answer.